This is a hypothesis testing question involving a normal distribution on one of our CCEA applied maths past papers. This one's from June 2022, and this then is question 8. So let's take a wee look then at what's being asked. So it says the manufacturer of nylon fishing lines claims that the breaking strength of its nylon fishing lines is normally distributed with a mean of 3.5 and a variance of 0.43. Following this installation of a new machine, the manager wishes to carry the hypothesis test at the 5% level of significance to see if breaking strength of the fishing lines is increased. In a random sample of 50, the mean breaking strength is found to be 3.7. Calculate the value of the standardized test statistic. So our mean is 3.5 and we want to see where 3.7 is on the normal distribution. So remember, because it's our sample here, we're going to use our slightly different formula. If you look at the previous video we did there for question 7, it was a normal distribution question. So it's going to be x minus mu all over the square root of sigma squared over n. So let's fill in our blanks there. Our value we're testing is 3.7 minus 3.5, which is our mean. I'm just being careful down here. That's going to be then, the variance is 0.43, so that already is the thing squared, so it's 0.43 all over 50. And if we stick that into our calculator, we get a z value of 2.16. So we want to see effectively where that is, and if it's in the critical region at the 5% level of significance. But 2.16 is our answer to part 1, so I'm jumping ahead there to part 2 and getting ahead of myself. Hence or otherwise complete the hypothesis test. So our H0 is that mu is as is and stays at 3.5. Our H1 then is that mu is greater than 3.5. So in that scenario we're going to do a one-tailed test at the 5% level. So 5% level of significance. So we're going to reject H0, as in we're going to say that the mean is no longer 3.5. If Z is greater than, and at the 5% level, again you can use these tables if you want. Some people are kind of well used to them anyway, so it's not 0.95. So we'd have here, so we want to add 5 to this, so it's 1.6. Now hopefully we're okay, you can see where I'm getting this from. So not point, it's right about here, so 1.64, and we want to add 5 onto this, so we're going to here, so it's 1.645. It's quite a well-known number for these hypothesis testing, and quite often, and I'm sure in your notes in school you kind of have those sort of set up for this at 5% level. It's greater than 1.5. Our test statistic is, of course, is 2, Z value is 2.16. So obviously 2.16 is indeed a bigger number than 1.645. So let's write that. So since 2.16 is greater than 1.645, we reject H0, and there is sufficient evidence at the 5% level to suggest, what is it we're testing here? The mean breaking strength